AI evaluation is starting to measure what systems do in the wild, not just what a model can answer in a static prompt. This week's results show that the harness around GPT-5, 4, Claude Opus 4.7, Gemini, or Qwen can materially change coding performance, that even strong models may confidently invent non-existent entities, and that autonomous driving systems fail at long-range geometry conventional datasets barely test. The common thread is deployment realism, interoperable agents, calibrated uncertainty, and multimodal tests tied to maps and sensors. We'll unpack what these signals mean for building reliable AI. Let's explore the first paper, Agent Beats Agentifying, Agent Assessment for Openness, Standardization, and Reproducibility. A team including Don Song at UC Berkeley proposes Agentified Agent Assessment, or AAA, which turns a benchmark into a judge agent and separates assessment logic from the evaluated system through the production-oriented A2A, protocol for task management, and MCP for tool access. Instead of bespoke benchmark agent integrations, AAA reduces the architecture to protocol-level compatibility, supports multi-agent evaluation, and offers 5 Agent Beats deployment modes covering local, remote, hosted, proxy, and continuous integration workflows. In a 5-month competition, Agent Beats attracted 298 judge agents across 12 categories and 467 subject agents, agentifying benchmarks such as Tau2, Bench, MedAgent Bench, Office QA, Osworld, and CyberGym. A coding case study evaluated Anthropic's Claude Opus 4.7 with Claude Code, OpenAI's GPT-5, 4 with Codex CLI, Google DeepMind's Gemini 3.1 Pro with OpenCode, and Qwen 35397B, A17B, with Mini SWE Agent on DevEvil, SWE Bench Pro, and Terminal Bench 2. GPT-5, VOR with Codex CLI reached a 94.8% solve rate on DevEvil, while Claude Opus 4.7 with Claude Code led SWE Bench Pro at 69.1%. A harness swapping experiment found native model harness pairings outperforming swapped pairings by an average of 5.3 percentage points, demonstrating co-adaptation and showing why model-only scores can misrepresent deployed agent performance. Overall, the paper argues that Agent Beats makes agent evaluation more open, interoperable, reproducible, and aligned with production behavior. Let's explore the second paper, Phantom Bench Benchmarking the Non-Existential Threat of Language Models. In Phantom Bench, Haiji Zhong and Hila Gonen of the University of British Columbia and AMI introduce a benchmark for testing whether language models recognize when they have no knowledge. The benchmark contains 62,411 linguistically plausible but non-existent terms and entities generated by blending words, recombining entity n-grams, and filtering exact matches against DOMA v1 and 7 with infinigram. The authors evaluate 21 models, including Llama, Gemma, Qwen, Mistral, Google's Gemini 2.5, OpenAI's GPT, OSS 20B, and DeepSeek R1, using prompts about existence, meaning, date, and place. Hallucination rates reach 86.7%, and presupposing that a concept exists is especially damaging. Models hallucinate far more when asked what an imaginary concept means than whether it exists. On the full benchmark, Gemma 312B has a 73.3% hallucination rate, while Llama 3.18b performs better at 7.3%, showing that model scale and capability do not guarantee calibrated abstention. Reasoning models and the largest variants in some families can hallucinate more, while domain-specialized models such as MedGemma and BioMistral are inconsistent. Most importantly, abstention on non-existent concepts correlates strongly with behavior on rare real concepts, with Pearson correlation 0.755, suggesting Phantom Bench is a practical proxy for long-tail knowledge reliability in high-stakes applications. Let's explore the third paper, The Road Ahead in Autonomous Driving, the KitScenes Multimodal Dataset. Researchers at Karlsruhe Institute of Technology and FZI Research Center for Information Technology introduced KitScenes Multimodal, a European autonomous driving dataset designed to test spatial reasoning in difficult urban environments. Its synchronized robotaxi platform combines 72.5 MPX global shutter cameras, 7 LiDARs, reaching a measured maximum range of 400 and 9.2 m 3,4D imaging radars, and redundant GNSS, INS localization, covering 62 square kilometers across Karlsruhe, Frankfurt, and Sindelfingen. The release pairs sensor data with reprojection-accurate Lanelet 2 HD maps that encode road topology, regulatory elements, and 3D traffic lights, signs, and poles, and are validated in the open-source AutoWare stack. 4 benchmarks target complete online HD map construction, long-range monocular depth, map-grounded novel view synthesis, and multimodal end-to-end driving. The results expose failures hidden by conventional datasets. Beyond 200 meters, UNIDAC achieves the strongest tested depth estimate, but only a delta 1 score of 1.78, while current novel view synthesis loses more than 80% of traffic sign recall at lateral offsets of plus or minus 3m. In open-loop driving, the strongest Epona configuration reaches a 98.3% collision-free rate at the 3-second horizon. Kit scenes is smaller than large corpora such as NVIDIA's Physical AI AV, but prioritizes sensor fidelity, geographic diversity, complete maps, and deployment-oriented evaluation for Level 4 autonomy. That's a wrap on today's AI paper highlights. Thanks for watching.